The first question is about understanding plots of solutions of differential equations. So there will be 6 plots. Each of these 6 plots shows 3 curves, so 3 solutions of some differential equations. And we are given that one of them is first order autonomous, one is first order linear homogeneous, second order linear homogeneous with constant coefficients, second order linear homogeneous with non-constant coefficients, and 2 are of order higher than 2. Okay? Now, question A. Which of the plots shows solutions of a first order linear homogeneous differential equation? So first order linear homogeneous differential equation is of the form y prime equals p of t y, or we can actually write it probably like this. But the important property here is that the set of solutions is a one-dimensional vector space, so it may have a basis, say, I don't know, y not. Okay, maybe let me write. Let's say that the function f of t is the basis of the solution space, which means that the general solution looks like y equals c times f. So in other words, all solutions are proportional to each other. So this is plot C. In plot C, we see that all solutions are constant multiples of each other. Question B, which of the plots shows solutions of a first order autonomous differential equation? So recall that autonomous differential equations is an equation of the form y prime equals some function g of y, and its characteristic property is that its solutions are obtained from each other by horizontal translation, or it is invariant under horizontal translation. So it is invariant under horizontal translation, and we have one plot that is invariant under horizontal translation. So here the red curve is an equilibrium solution, is a constant, and the 2 other curves that they are obtained from each other by horizontal translation. So this is first order autonomous differential equation. Question C, which of the plots shows solutions of a second order linear homogeneous differential equation with non-constant coefficients? Well, basically, non-constant coefficients is whatever you are not familiar with. Maybe let us try to look at all the plots here. So notice that plot C we have ruled out because it is a first order linear equation. Plot D we ruled out because it is a first order homogeneous equation. So then look at plots E and F. So in plots E and F, there are some points where these solutions share a common tangent line. So it means that sharing a common tangent line would contradict the Picard and Deleuze theorem in dimension 2. So which means that the order of differential equations in plots E and F is at least 3, right? So E is out, F is out. Sorry, I mean, of course, C is also out. Is not none of this. D is also out. So we're choosing between A and B. So which of these plots shows solutions of a second order linear homogeneous differential equation with non-constant coefficients? Well, basically, if the coefficients are constant, then we know all possible cases. So constant coefficients and homogeneous differential equation is either oscillation or a combination of exponential function. So in plot B, we see oscillation. So whatever is not covered by familiar cases has to be the answer. And this is plot A. Question D, which of the plots correspond to ODE of order higher than 2? Well, actually, I just explained it. Is that since we know that there are 2 of them are of order higher than 2, and at the same time we see that plots E and F, since they have points where solutions sort of touch, where they have a common tangent line at the point of intersection, this is incompatible with order 1 or 2. So it means that in plots E and F, the order has to be of at least 3. So E and F are definitely there. And since we are given in the question that two of these differential equations are of order higher than 2, it means that it's E and F. Okay, and the last question, so we need to identify the linear homogeneous differential equation with constant coefficients, and then we need to figure out what the sign of the expression b squared minus 4c is. Well, notice that a second order linear homogeneous differential equation with constant coefficients, it could only be like one of several cases. So the solution could be either a combination of exponential functions, or it could be something with oscillations, and this is plot B. We see oscillations. So we see something like e to the power lambda t times c1 cosine mu t plus c2 sine mu t. And this happens if the roots of the characteristic equation are complex numbers. So which means that the discriminant of the characteristic equation, which is exactly b squared minus 4c, is negative. So the answer is that it is negative. The sign is minus.